Hello, good evening, everyone. Please join the peer deck. Link is can you see the link on the screen? This joinpd.com is the link, and this BURKJM is your password. Yes, this is the link, joinpd.com. Password is here, BURKJM. We will wait for 5 minutes for others to join. Then we'll start. Those who have joined the session, please join the peer deck so that you can answer there and the session will be interactive then.
Excuse me, ma'am. Excuse me. Excuse me.
Okay, let's start. Good evening, everyone. Let's join the peer deck. Whoever are joining late, please join the peer deck. We will having this joinpd.com is your link that is pasted on group chat, and there is a code. Please write code without space. BURKJM. Okay. Yes, to solve the questions, please keep your notebook and pen ready, and
Excuse me, ma'am.
please answer on the peer deck. Let's start.
Excuse me, ma'am. Excuse me, ma'am.
We will first discuss some definitions of experiments and random experiments. Okay, so what is random experiment? My voice is clear to everyone?
Excuse me, ma'am.
Yes, ma'am. Your voice is clear.
Hello.
Yes, ma'am. Your voice is clear.
Excuse
Am I
me,
audible?
ma'am.
Yes, ma'am.
Yeah,
You are
yes,
audible,
ma'am.
but
Audible.
voice is low.
Hello.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So yes, random experiment. So any experiment in which outcome is not predictable with certainty, it's called as random experiment. For example, if there is a box, in that box some 3 red balls are there and 3 black balls are there, and someone is like picking a ball randomly. Randomly means why we say it randomly. If anyone will pick the ball,
Right.
what will happen, like without we are like picking the ball without like shaking it, okay, just one ball is picked up. So now can you guarantee that that ball will be red?
No, ma'am.
No, right? Can we guarantee that ball will be black only? No.
No,
Such an
ma'am.
event where you know possibilities of outcome, you know that if we pick the ball, either it will be a red ball or it will be a black ball, but you can't guarantee that whatever the picked up ball is of particular color with 100% surety. So such an event is called as random experiments. Okay, such experiments in which you don't know what your outcome will be. You know possibilities of outcome, but you can't guarantee, you can't predict with some certainty, no, that ball will be definitely red ball. Okay, such an experiments are called as random experiments. Okay, then we move to sample space. What is sample space? So sample space is the collection of all possible outcomes. Whatever the possibilities of outcome in certain experiment are, we collect in a set, and that set, that collection is called a sample space. Okay,
Sample space.
then events. Yeah, outcomes
Ma'am.
or combination of outcomes are termed as event. That is, an event is a subset of sample space. For example, in this ball experiment, when you pick up any ball, let's say that ball is red, then this red is your picking up the ball, and the ball is red is your event. Similarly, if black ball is black, then we say it is a event. If someone picks up 2 balls, so it may be possible that one red and one black ball will be picked up. So it is also one of the event. So these events are always a subset of sample space.
Sample space.
Because in sample space, we consider all the possible outcomes, okay? So this event is a subset of sample space. Then subset, yeah. If for any event A, and B, if all the outcomes in A are also in B, then we say that A is a subset of B. Let us consider the example of throwing a die. Okay, you throw a die. Then what will be the possibilities will be there? Outcome will be either 1, 2, 3, 4, 5 or 6, right? This can be the outcome. If like there is a condition that you have to just collect only that outcome, you want only that event in which only even numbers are on the face, then what will be your event be? It will be either 2, 4 or 6. Whenever this 2, 4 or 6 are there, we will take it as a B. So this event B is a subset of A. Why? Because all the events, all the elements in B are already present in A. Okay. So
Okay.
we say B is a subset of A. Okay.
Okay, ma'am.
Yes, ma'am.
Okay. So let's move to the question part. So yeah, here is the first question. Consider the following experiment, selecting a family out of a given group of families. Experiment B is selecting a card from the pack of playing cards. And C is rolling a die and noting down the number on the upper face of the die. Question is, which of the following is a random experiment? Okay.
Ma'am,
So
4.
I will give some time. You just check and answer on the peer deck.
Ma'am, option 4.
Code is given on the right corner of the screen. BURKJM. Okay, so what are the experiments here? The first experiment is selecting a family out of the given group of families. So in this case, we can't predict exactly which family will be selected. So this is a random experiment A. Then next, selecting a card from the pack of playing card. In a deck, there are some 52 cards and we are out of 52 cards, we are selecting one. So we don't know exactly which card will be drawn. So this is also a random experiment. Random experiment are those experiment in which we can't predict with certainty that only this outcome will be there. Okay. Then rolling a die and noting down the number on the upper face of the die. So here also there are 6 possibilities, but we can't claim that only one will be there if we throw a if we roll a die, okay, 1 or 2 or any number, we can't say with certainty only this will be there. So that's why this is also a random random experiment. So here all the experiments are random experiments. So the correct option is 4 only. Okay, anyone have a doubt here? Then please ask.
No, ma'am.
Okay. Fine. And those who have not joined peer deck, please join the peer deck so that you can answer there. Okay. So this is explanation here, which we already have discussed. So let's move to question number 2. After throwing off 2 dice, Ramesh gave the following statement. First, there are 5 ways of getting the sum of number as 5. And the second statement he gives is the experiment is not a random experiment. The third statement is getting the sum of 12 is an event. Okay. So we have to check which of the following statement is true. Okay. I will allot some time. Please try and answer in the peer deck. Okay, I will give some extra time again because many of the people unable to answer within that time. Okay, extra 1 minute. Okay, so we'll first check in this question. We have to check the statement whether they are correct or not. So for the first statement, the claim is there are 5 ways of getting the sum of the number as 5. So when you throw a die, when you roll a die, what are the possible outcomes? Possible outcomes are 1, 2, 3, 4, 5, and 6. But here they are throwing 2 dice. Okay. So the possibilities, the sample space will be in pair, like 1, 1, 1, 2, and so on. This will be your outcome, and so on. Okay, till or considering all the possibilities. How many possibilities will be there? So yeah, for first position there are 6 chances. For the second position there are again 6 chances. So 36 outcomes are possible here. Okay, so out of this 36, we will first check ki how many like there are how many ways that the sum of that pair is 5. Okay, so just check it. So what are the possibilities here so that sum will be 5? So for this statement, the possibility will be like 1, 4. Okay,
Ma'am, 1, 4, 4,
1,
1, 2,
4,
3, 3,
2,
2.
3,
then 2, 3,
3, 2,
3, 2,
4, 1.
4, 1. Is there any other chances so that we can say that the sum is 5?
No, ma'am.
Okay,
No, ma'am.
so there are no other chances that sum will be 5. So here we have only 4 chances, 4 ways. There are only 4 ways that sum on the numbers that dice show will be 5. So there are only 4 ways. So this first statement is incorrect. Okay, let's take the second statement. What it says, the experiment is not a random experiment. So while throwing a 2 dice, we can't predict which number will be shown. It might be either, it may show 1, 2, it may show 6, 1, or any out of 36 outcomes, any possible outcome it can show. So we can't guarantee any particular outcome. So this is a random experiment. So this statement 2 is also a false. Now, the third statement says getting the sum of 12 is an event. So is it possible that out of this 36 outcomes, is there any event in which you get the sum on the sum that number shows are 12? So yes,
Yes.
when
6
there
and
is
2.
a 6 on the first die and 6 on the second die, the sum will be 12. So this getting sum of 12 is event. So yes, it is correct. So your option C is correct here. Okay, anyone has doubt in this part?
Yeah, ma'am. In option number 1,
Okay,
can
so we
we
will move ahead.
interchange?
Ma'am, repeat option
This
3.
is
Hello.
your explanation. The number of ways to get 5 as a sum of number is only
Yeah, ma'am. We can
there
also
are only 4
interchange.
ways. So statement 1 is correct. And from the
Ma'am, can you
definition of
repeat
random
option 3?
experiment and events, the statement 3 is only correct here. Okay. Then next. Okay. 2 unbiased dice are thrown. Find the probability that both the dice shows the same number. Okay, we have to calculate here. I will give you time. Please check it
Excuse me, ma'am.
and write in the periodic.
Excuse me, ma'am. Am I audible?
You are audible, but I think we are not audible to ma'am.
Yes, I think you are not audible to ma'am.
Yeah.
Right on chat, I think.
Okay. I think if you are like saying anything, then please unmute first.
Hello, ma'am.
Ma'am? Excuse
Just
me,
a
ma'am.
minute. Just a minute. Let me check. Hello.
Hello, ma'am.
Sorry. Yeah, there might be some technical problem. I was not able to hear.
Now I am audible, ma'am.
Yes.
Yeah, ma'am, I have a doubt in a previous question in option
Okay.
number 1.
Okay, fine. Okay, just the timer get over, then we will discuss that. Okay, just a minute.
Okay, sure, ma'am.
Sorry
Thank
for
you.
that.
Okay, no issue.
Okay. Please mute yourself if you are not. Okay, so done? Or you need extra
Yes.
time then?
Yes, ma'am.
Maybe some people were not able to do it, so I will just give 1 extra minute. Please answer there. And those who have joined late, you can join on the peer deck and please answer there. Okay. I hope you guys have did it. So first we will discuss this question, then previous question, whatever the doubts are, we will discuss that. Okay.
Okay.
So two unbiased dice are thrown. Find the probability that both dice shows the same number. So how will you calculate? So out of these 36, again 36 possibilities will be there, right?
Yes, ma'am.
Yes, ma'am.
So out of these 36 possibilities, what are the events when both the dice have the same number?
Ma'am,
So
6,
just, yeah,
Six.
this 1, 1,
2,
2,
2,
2,
3, 3,
4, 4,
4, 4,
5, 5,
5, 5, and
6,
6,
6,
6.
6, 6. These are the only possibilities, right?
Yes, ma'am.
So there are only 6 possibilities, but we have to find the probability. So how will you calculate the probability?
Ma'am,
6.
Total favorable
number of
outcome upon
36.
1
number.
upon
Probability of any event is number of favorable outcomes.
total out number upon total.
Means 6 upon 36.
Yeah.
No, ma'am, 1 upon 6, I think.
So 6 upon 36 and 1 by 6, both are the same only.
Yes, ma'am.
Yep.
0.16.
Total outcomes. So this will be 6 upon 36. That is nothing but the 1 by 6,
1 up.
right?
Yes, ma'am.
So this was the correct answer.
0.16.
Yeah.
Ma'am,
Yes.
ma'am, I have a doubt here. Ma'am, why it is specifically mentioned unbiased? Like, I get the
Yes.
point, but if it was biased, then
Yeah. I will discuss that point. So when we say biased, unbiased, that means, see, there are equal chances. Just a minute.
Also, ma'am, what is
Unbiased.
fair?
Sorry, unbiased and fair dice, both are the same thing. If you say unbiased, that means if you throw a dice, there will be equal chance for one to be there. Like if you throw the dice, then the probability that one will appear on the upper face is equal to probability of 1 is equal to probability of 2. What is this probability? This probability of 2 means for this example, I am just considering only one unbiased dice is thrown. Okay. When one unbiased dice is thrown, what are your outcomes are? Your outcomes are 1, 2, 3, 4, 5, and 6, right? So when you throw the dice, what is the probability of 1?
1 by 6.
1 by 6, right? 1 by 6. What is the probability of getting 2?
1
1
by
by
6.
6.
1 by 6.
So here, probability of getting any number, it's either 1, 2, or 3, or any number, are all 1 by 6, right? Is there any doubt? Like
Yes, ma'am.
all these probabilities are equal, and these equal
Correct.
probability, and they are equal to 1 by 6. Why this happened? This happened due to that unbiasedness of the dice. Okay, if this
Yes.
dice, or firstly, that unbiased and fair dice both are the same thing. Okay, this is just a language, that's all. And when we come to when there is a biased biased die mean it is sometimes loaded die, like it's manufactured so that the probability of getting 1 or any number, I am just taking example of 1 only, a probability of getting 1 or any number is larger, like is more biased toward 1, getting 1, like it's loaded. So whenever you throw the dice, generally people will not load to get 1, they will load to get 6 only, right? So that the chances of their winning is higher, right? So if it is loaded so that the probability of getting 6 is some 1 by 2. So obviously, if probability of getting 6 is 1 by 2, then this probability of getting 1, 2, 3, 4, or 5 will be less, right? It will not be
Yes.
equal to 1 by 6. And in that case, if you play with that kind of dice, will your game will be fair? No. So whenever you want to experiment such a, like there is an experiment in which there is unbiased dice, they are saying that means the probability of getting any outcomes is equally likely. Equally likely means the probability of each and every event is same in this case, like that. Okay, do you understand what is the difference here, or still have any doubt?
Yeah, understand, ma'am.
Okay. And very basic example for this unbiased and fairness is, have you heard about biased coin?
Yes, ma'am.
Yes.
In biased coin, what happens? See, let's say it is loaded more about head, and tail is obviously, if it is loaded toward head, so whenever you throw, the maximum chances you will get head only. So this kind of biasness they can create using like manufacturing defect or sometimes intentionally. So this type of question you will also face in this course when we go ahead. Okay. So for this point of time, biased unbiasedness is clear, right? Okay. If there is any still doubt, then please ask me. I will explain.
No, ma'am.
Okay.
No, ma'am.
So this is just explanation here, what you have calculated, right?
Yes, ma'am.
Okay. Then someone has question on the last previous question. What was that, please?
Yeah,
Okay.
yes, ma'am. I have a doubt in question option number one. Here you said there are only four way, 4, 1, 2, 3, and 3, 2, and 4,
Yes.
1. If we interchange the first dice will get 4 and the second dice will get 1, then I think the outcome would be there would be 8 ways.
Okay, how it is 8-way? See, we will again calculate it. Okay, when we said 1, 4, whenever we place our outcome as A, B format, that means this A is outcome of your first dice or whatever
Yeah.
your first incident is, and this is for second die. Okay,
Yeah, yes.
so first possibility we took is 1, 4. That means on first die you have landed up with 1, and for the second die you landed up with the 4. Okay,
Yes,
this
yes,
is one
ma'am.
possibility. Then the second possibility was 2, 3, right?
Yes,
The first
right.
die, the second die. Okay, we will
Yes.
just not be like that. Okay, now what is our third possibility? It is 3, 2.
3, 2.
That means what? Your first die has
Yeah, 3.
landed at 3, and this is at 2. This is your
Yes.
first die, this is your second die. Okay, and
Yes.
the fourth possibility what we have shown is 4, 1. So already
Yeah,
we
yes. Yeah, already we included. Okay, ma'am.
Yeah.
Thank you.
Okay,
I got it.
okay.
Ma'am, can you repeat this in this option 3 in this question?
Yeah. So what is the option 3 here? See. Now, getting the sum of 12 is an event. So
Yes, ma'am.
getting the sum, when we have this type of pairs, how will you get the sum 12? So is there possibility using like you have to just, the question changes like that. Ki if you have the pairs like 1, 1, 1, 2 till 1, 6, right? And similarly 2, 1 till 2, 6.
6. Yes, ma'am.
Okay, till we will continue till we get 6, 1, 6,
Till
2,
6,6.
right? Till
Yes,
6,
ma'am.
6. Okay. So these are 36 outcomes. In this outcome, is there any possibility that sum of this pair becomes 12?
Yes,
So
ma'am. 1 is there. 6 plus 6.
6 plus 6. So this is the only event when 6, 6 can happen, and the sum will
Yes,
be
ma'am.
12. So
12.
yeah. So when you throw the dice such that your first die landed at 6 and second also landed at 6, this is an event, right? What is event?
Yes, ma'am.
Event is when you perform the experiment, whatever the outcome, you get to know as the event, right? So this that sum of getting 12 is an event, right?
Yes,
So
ma'am.
that's what it was asking, ki, is there any possibility that there is an event such that the sum is 12? So that's why it was correct. You got the point, or?
Yes, ma'am. I got it.
Okay. So similarly, if the question changes that getting the sum of 13 is an event, then what will you say? Is it a true statement or false?
It's obviously incorrect.
It's incorrect, right? It's a false statement because
Yeah.
we can't have more than 6, 6. The sum is the highest. Okay.
Yep.
Okay. Let's move to next question. Okay. This is done. Yeah. Two unbiased dice are thrown. Find the probability that the first die shows 6. Okay, you just try this question. Okay, done or
Yes, done.
Yes, ma'am, done.
okay, fine. So we have to calculate probability that first die shows 6. So now if 2 dice are thrown, so how many possibilities are there? So we'll just calculate, right?
36.
Okay. 36 is total outcome. Here is one condition that your first die should be 6. When you calculate the all
Ma'am,
possibilities,
6 possibilities, I think.
6
y-
upon
yes.
6,
So,
1, 6, 2, 6, 3, right?
okay. So what are the event in which first die will show the 6? So your first position should be 6. So second
6,
position, what it can take? Either 1
1, either 2,
or
3.
2, 3, 4, till 6 it can take, right? Okay.
Yes, ma'am.
6, 4, 5 until 6 it can take. So there are 6 events in which your first die will take
6,
6. And how we want to find the probability. So probability of this event is
1 by 6.
yeah, yes,
1
6 by
upon 6.
36,
6
which
upon
is equal to
36.
yeah, both are the same. So you have to just calculate this only. Okay. So yeah, this is the explanation here. And then next question. 2 unbiased dice are thrown. Find the probability that total number of numbers on the dice is greater than 8. When number means here we are like thinking about sum only. Okay. Mm, 8. Yeah.
Number 6.
Please answer on the peer deck. Those who have joined and are not able to answer, then please, like, don't answer on the chat. You have joined the peer deck, so please answer there only. If you need extra time, then just tell me, I will allot. Okay, fine. So two unbiased dice are thrown, and we have to find a probability that total numbers on the dice is greater than 8. So what are the possibilities there?
Ma'am,
So we want the sum to be greater than 8.
3,
So
6.
yeah. So yeah, just calculate the what are the events where we get sum to be more than 8. So
8.
one is 3, 6,
6, 3.
6, 3,
4,
4,
5.
5, 5, 4, 4, 6, 6, 4, 5, 5, 5, 6, 6, 5, 6, 6. So how many it is? 10,
10.
right?
Yes, ma'am.
So 10 possibilities are there. So probability of getting total of more than 8 are 10 by 36.
36.
Okay? Because total outcomes are 36.
36.
So that was like that. Okay. Should we move further?
Ma'am, hello.
Yes.
Ma'am, I am getting 10 by 36 as 0.27.
How?
Ma'am, 10 divided by 36 equal to 0.27.
Ma'am,
It
can
will
we
round
use
off.
combination
madam,
formula
no.
Round off, maybe round off.
36C10?
Just a minute.
Round off answer.
One by one.
0.2777.
One by one, one by one. It's not possible like that. Okay, if you all will speak at a time, I will not be able to answer. Yeah, when there is some number like 0.27777 and 7 is like that, then you can round it of 2 8. Still, both like since this after 7 this is not like varying, so we can round it as a 0.28. Okay.
Okay.
Ma'am,
Okay, ma'am.
Yeah.
ma'am,
But
can we use combination formula 36C10?
36
C10.
C10.
Yes,
When we
ma'am.
say 36 C10 combination formula, that means, what does it mean? Combination formula means out of 36 36 possibilities, you are considering any 10. 36 C10. What does it mean? Ki out of 36 items, you can choose any 10 items. But is this the case here? Can we choose any 10 items here?
No.
No, ma'am.
No, right? Because the condition is your sum should be more than 8. So when you choose any 10 items out of 36, then one may choose 1 comma 1. So
Yes, ma'am.
this is not a right choice, right? This is wrong choice
Yes,
because
ma'am.
we need sum more than 8.
Okay, ma'am.
Okay,
Okay.
fine.
Okay.
Okay. So there is a next question. Yeah. If probability of C is equal to 0.2 and probability of A union B is 0.5 and the probability of A union B union C is 0.6, then what is the probability of A union B intersection C? Okay, just try it. Okay. Do you guys need more time to answer this question?
No, ma'am.
No, ma'am.
Okay, but many of people have not answered. Okay, I will just give some more time, some 30 seconds. Okay. So in this question, you need some like set rules, right? Okay. So what they have given, probability of C is 0.2 and probability of A union B is given and the whole union is also given. So what they are asking, probability of A union B intersection C, right? So can we just like for the sake of our like easy, it will be easy if we consider this A union B as a D or any number. Okay. So this is equal to probability of D intersection C. We have to calculate this one only. So how will you calculate D intersection C with given that your probability of C is given, probability of C is 0.2 and A union B, we have considered it as a D. So let me write this. A union B is equal to D. That means probability of D is 0.5 and probability of A union B union C. That means D union C. Okay, we can write this 0.6 and now they are asking for intersection. So from this much of detail, you can easily find probability of D intersection C. How? Using addition rule of set. What is that? Anyone? Okay. It says probability of C union D is nothing but the probability of C plus probability of D minus probability of
C
D intersection D.
intersection D. So now is it easy to just calculate this equation, just putting the values and calculating the probability of D intersection C. So what is C union D? It is 0.6. Probability of C is 0.2. Probability D is 0.5. And this is C intersection D. So, okay, direct 0.7, 0.6, 0.1. Is it okay for everyone?
Ma'am,
Yes,
but in question only given probability of C is 0.2, not D.
Probability of D, I have considered A union B as a D. And we have given that probability of A union B is 0.5. So, and I have just assumed that probability of D, like A union B is my D. Just for simplification, that's all. Like, even though you will not do that is also fine, no problem. Okay? It was
Okay,
just a notation I have changed, that's all.
Ma'am, we
Oh.
can use Venn diagram for the same.
Yes. Do you want like that? We can do like that also. It's not
Yes.
yeah, we can check. See. Okay. We have A union B, A, B, and C you have, right? So again, I can tell A union B is a D. Okay, is it okay with everyone? A union B is my D, and as there are like this is my some, let's say, C. Okay, and this is some D. Okay, so C union D means the whole part. Okay, this whole part will be my C union D. And the C intersection D, like we are interested in finding this value, C intersection D. Okay. Rest we have given probability of C is given, probability of D is given, and union is also given. So we will just go by addition rule, which says that probability of C union D is equal to C probability of D minus intersection, probability of both, intersection of both. So we'll just put the values and we'll get. Okay. Is it fine?
Yes, ma'am.
Oh,
Yes, ma'am.
Yes, ma'am.
so let's check next question. What is this? Probability of C is 0.2 and probability of A union B is given 0.5. And probability of A union B union C is 0.6. The same question again. What is the value of complement of probability of A union B union C? Okay. It's your choice. If you do not want to consider A union B is D, that is also fine. If you want to take, that is also fine. It's just a notation. We are not changing anything. Okay. So here we need to calculate the value of complement of probability of A union B union C. So here directly I can say this, like I will assume, like not necessarily, it is not necessary to assume, but just simplification in writing it will be easy. Let's say A union B union C, I am denoting it by, let's say, E. Okay. So I want to find the probability of E complement. So what is yeah. So what is E complement? Probability of E complement is what? Anyone knows? What is it?
1 minus
minus.
probability of E.
Yeah. So it is just 1 minus probability of E. And do we know the probability of E
Yep.
from the question?
0.6.
Yes, ma'am. 0.6.
0.6.
So it was very easy, like 1 minus 0.6 and
0.4.
is 0.4. Okay. Fine.
Yes, ma'am.
Okay. Let's move to next one. What it says. Next question. This is just an explanation again. Yeah. An urn contains 6 white, 4 red, and 9 black balls. If 3 balls are drawn at random without replacement, then find the probability that one is of each color. Okay. Just calculate it. It is also Okay. So let's understand the question first. What it says: an urn contains 6 white, 4 red, and 9 black balls. If 3 balls are drawn at random without replacement, then find the probability that one is of each color. Okay. So out of this 6 plus 4 plus 9, 13. Sorry, 19. Out of this balls, we have to calculate. We have to pick 3 balls, but such that without replacement. That means if you pick up the one ball, you can't put it again. Okay. So you have to like pick 3 balls from there. So how will you do that? And the condition is we want to pick 3 balls such that one is of white color, one is of red color, and one is of black ball. One is of black color. How how will you calculate the probability in this case? So we will start yeah. So how many white balls are there? So let's say
6.
white, red, and black. Yeah. White balls are 6, red are 4, and black
4,
9.
3.
Okay. And we are picking up or drawing any 3 balls randomly. So it may be possible that all are red, all are black, all are white, but we need one from this, one from red, and one from black.
Yes, ma'am.
Okay.
Yes,
From
ma'am.
all this collection, we need one. How will you choose that? So there is one concept we have learned that is
6C2.
of combination. No.
Oh man, 6C1,
Yeah.
4C1.
Ma'am, we will do by 6 by 19 into 4 by 18 into 9 by 17.
6 by,
First of all, 6 by 19
yeah,
into 4 by 18
yes,
into 9 by 17.
yeah. Okay. Uh, we will take it. Okay.
We can
This,
use 6C1 into 4C1 into 9C1.
yes, we can use that also. So,
Divided by
And I got 260.
sorry. Hello. Hello. Am I audible?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. So yes, these are also a way, and yeah, we will go for a combination first. We want to choose a one ball from white collection of white, one from the red, and one from the black. So out of this white balls, how many possibilities are there? So how many
6%.
ways you can check, how many ways you can find out the white balls? So it is 6C1, right?
Yes, ma'am.
So out of 6 white ball, we need one. And, right, when there is an and statement, we will multiply it. And one red ball.
4C1
So 4C1 multiplied by
and
9C.
9C1
This will give you number of ways how you can
upon
take
divided
this
by
3 balls such that all are like each of each color you will get one ball. Okay.
and divided
And
by 19C3.
yeah, because the total is 19 and out of 19 balls you can choose any 3 balls. So this will be your one of the solution, but the someone has told this 6 by 19, 4 by 18, and 9 by
But ma'am,
17. Yeah.
But on
Yes,
in the
correct, ma'am.
question it
when
is
we
mentioned without replacement.
Yes. But still this one is correct. Even both are same. You just calculate it. You will find out what is 6C1.
Yeah, yeah.
It is 6.
Both are not
on
same.
6
upper
into 4
numerator you
into 9.
got
Just one by one. If
216.
if all will speak together, I
In
will not
numerator,
do. Yeah.
in numerator you got 216.
216.
Yes, ma'am.
Sorry.
Ma'am, both will not be same because
Yes,
yes, ma'am.
I want to point it out, like whoever has answered this, for them only, why they are not same. There is one mistake here. Not one mistake, one
Yeah,
catch is
ma'am.
there.
What is the correct method for this
Because
Ma'am, it
question?
should be
yeah,
19P3 then.
yeah, because here we are using permutation, and we here order doesn't matter in our case. So that's why this second case is not okay. Okay,
Okay, ma'am.
fine. Okay then. Let's go. Is it fine for this question? So we have to just calculate these values and we are through. Okay. Let's move to next one. Anyone has doubt in this question now? Till now?
No, ma'am.
Okay.
I'm sorry. Can you just explain that 6C1 multiplied by 4C1? I mean,
Yes.
how do we actually go for it? I mean,
Yeah.
I understood the total number of combination. There is a 3 taken. It is 19C3. That's understood. But
Okay.
yeah.
Yeah. So we need there are some 6 white balls. There are some 6 white balls plus some 4 red balls and plus some 9 black balls. And we want to choose 3. So you are okay with this 19C3. That's not a problem, right? So
Yeah.
Because total number of balls are 19 and we have to choose any 3.
Yeah.
Now, so when there are 6 white balls, how many ways you can choose? You have to choose 3 balls.
Yeah.
And out of 3 balls, 1 ball should be white. So
Okay.
out of 6 ball, how many ways are there such that you will choose 1 white ball? So this is out of 6 balls, you have to choose 1 ball. Okay.
Okay.
Plus, we need one more condition that we don't want to just choose 1 ball only, right? So along with this condition, we want one more event so that one of the red ball can be chosen from this out of this 4 balls.
Yeah.
So how will you get that? This is
4C1.
4C1. But still, there is a question, we will add this or multiply this. So
since we have to collect all 3 together, it's and. So it's multiplication.
It's multiply. Okay. And now we have chosen the 2 balls. Now we are looking for the third ball, and that third ball should be from this 9 balls, 9 black balls.
So 9C1.
Yeah, it is 9C1. Is it okay?
See, I understand this, but my point is, how do you arrive at this? When, intuitively, how do you get it? Like that's
See, the question was that one probability that one is of each color. Each color. Yeah, this was a word where we got that we have to go with this things, because there is only combination in which order doesn't matter, and we can choose out of given items. How can we choose the required number?
All right. Okay. I mean, mathematically, it's perfect. I understood that.
Okay.
But if I'm given this question again independently, I don't know if I would approach it the right way. Okay.
Okay. I think that will come with the practice.
All right. Okay. Thank you.
Ma'am, there was one more hint. It's given without replacement, so we can go to the permutation and that combination concept.
Yes. Okay. So, do you have any doubt from there without replacement? See, there is a without replacement. That's why we are doing that. Otherwise, if there was a with replacement, then scenario might be changed, because then your denominator, total number of outcomes, will be changed, right?
Yes, ma'am.
Ma'am, then we cannot use
Yeah, so maybe this is the one that's confusing to me. Without replacement, isn't it? Even with replacement, don't we have the same solution?
19C3 or 19P3.
Yeah. When there is a with replacement, what is the scenario? Then let's say for the first ball, you have some 19 choices, right? 6 plus
Yes, ma'am.
4 plus 9. These 19 choices you have. At that time, out of this 19 balls, what is the probability that you will get one white ball? Then you have to go like that.
19P1.
No, no. Again, the total number of events will be 19C3, the denominator, correct?
Yes.
Okay, and on the top, with replacement or without replacement, I mean, even with replacement.
Let it be. See, when there is a with replacement,
Yeah.
just I'm just not just forget about this scenario, okay? And
Okay.
just tell me if the question is there are 6 white balls, 4 red, and 9 black balls, and you have to choose one white ball.
Okay.
So, what
60.
is so how will you calculate 6 by
6 upon 19.
6 upon
19.
19? Okay, fine. If I say
Okay.
again, I have to calculate, again, I have to pick one white ball. But the condition is, I am giving with replacement. So how many choices you have again?
For white ball?
For white ball, how many white ball left now?
Again 6.
Again 6. Why again 6?
Because,
Even though you have selected one,
yeah, we
still
are
6.
replacing it. Yeah.
Because we are replacing it. 6
Yeah.
out of
19.
6 by 19, right? Okay.
Okay.
The same thing we will apply here. Let's say
Okay.
we have to find the probability that one is of each color and with replacement. Okay,
Okay.
let's just get it. How will we do?
So wouldn't it be the same like for without? Because it doesn't really change which ball we are replacing, isn't it? The number of ways we can select one white ball out of 6 will be 6C1. And again, the number of red balls that we can select out of 4 will be 4C1.
Yeah.
Wouldn't it be the same answer? I mean, that's where I'm getting confused.
Yeah. Let's think about this. When there is a with replacement scenario, then we can't choose 3 balls at a time, right?
Okay.
At this time, this 19C3, like, yeah, you can say 19C3 is possible there because out of 19 ball, we have to just select 19C3. That's all.
Yeah.
Right? This will be
The base.
this
Denominator.
is okay, no problem. So now we have to choose the one white ball. How many possibilities will be there for just choosing the white ball? Forget about
C1.
rest. 6C1
C1. Yeah.
divided by 19C3, right? Sorry,
Oh,
19C1 it will be.
yeah. Okay. We are going to select one by one here.
Because we have to replace every time, right? So now,
So this is going to be different. Like this is going to be like one by one, not
yes.
3 at a time.
Yeah, because when you have to replace, you have to put back that thing, now what you have chosen.
I get it. Okay.
So let finish this question still. 6C1 divided by 19C1, right? Out of
Okay.
19 ball, you will choose one ball.
Fine.
Now multiply. You have to choose another ball, which should be red. So
Yeah.
now it will be 4C1 divided by
same 19C1.
19C1. So the difference you observed, where is the difference?
Yeah, instead of 19C3, it's going to be 19 cube.
Yes. So now again we want some one black ball, right? So this will be a 9C1 divided by 19C1 again, right?
Okay.
So this will be cube here. So this outcome, this original, like total number of outcomes will change here.
Yeah, and most importantly, what we have to realize here is, if it is with replacement, we cannot draw 3 balls at a time.
At
It
a
should be
time,
one
yeah.
by one.
Yes.
Okay, that's very important.
Because when you have some 19 balls, okay, 19 balls you have only. So,
okay.
And the scene is you have to choose each ball with replacement.
Correct.
So
Yeah.
once you drawn one ball, so now you are left with the 18 balls.
Yeah.
So
we replace it
so you
again.
have to put that ball again, so it becomes 19. And
19.
out of this 19, now you have to choose one.
All right. Thank you so much.
Okay. Anyone have a doubt further here? Okay, fine. So should we move next?
Yes, ma'am.
Okay. So yeah, this was the calculation here. Just that you should have done. Okay. So same question again, but what we have to find the probability that none is of red color. Okay. I hope you might be able to do this.
Ma'am,
Okay.
could you please just give me 5 seconds more? I was just entering the answer.
Okay, fine.
Thank you, ma'am.
Yeah, sure. So there are some, okay, this 15 balls again, and the condition is none of the balls should be red color. Then how will we do that? So in this case, when we don't want any red color, then we will change our like we will
90
just
minus
will not
4.
consider, yeah, will not consider the red balls. So
Ma'am.
while choosing the 3 balls, and out of these three balls, there is condition on the red color only. So in total, we have some 19 balls, but because the condition is it should not be red, it should not be of red color when we are choosing 3 balls. So some 6 plus 9, like when the ball is not of red color, that means either it is of white color or black ball. Okay, or
15.
one white, one ball, or
So,
like
ma'am,
that.
the answer becomes 15C3 by 19C3, right?
Yeah. So out of these 15 balls, how many we have to choose? 3 balls. So this will be 15C3, and total outcomes is that will remain as it is 19C3. Is it okay? Anyone has doubt on this thing? How to take these things? Anyone?
Ma'am, why is this 19C3 and that 19P3?
Okay. See, whenever we calculate probability of any event, we want to check the probability that none is red ball. Okay. So when we are saying whatever you choose, that should not be of red color, but you have to choose, still you have to choose three balls, right? How will you choose that?
19C3.
So, no, that is 19C3. 19C3, what does it mean by 19C3? There are some 19 balls. Out of that 19 ball, you are choosing 3 balls. But how did you come with the number 19? Some 6 white balls plus 4 red balls plus 9 black balls, right? This sum is 19. That's why you came with this 19C3 number, right? This is your total outcome. Like this is your total number of outcomes, possible outcomes, okay? I am just saying is total outcome. But what is your favorable outcome here? Favorable events, what are that? In that events, you need out of these 3 balls, no ball should be of red color, right? We don't want red color to be chosen. So when you randomly choose any 3 balls out of this 19, so there will be one possibility that one ball is red, one is black, and one is white. This is possible, right? One is red, one is black, another is black. This is also a possible. But the condition is we don't want any red color to be chosen. So these 2 cases are failed here. So how will you check that? How will you confirm that no red ball is chosen? So for that, so condition is not to choose red. That indirectly or directly implies what? That whatever you choose the ball, that ball will be either of white color or black or like, okay. So out of these 3 balls, it may be possible that all are white. Whatever you choose out of 6 balls, like out of remaining balls, just the condition is not to choose red. So when the condition is not to choose red, why to consider these 4 red balls? Just forget about these 4 red balls when you are choosing the balls such that it should not be of red color, right? Okay. Are you getting my point? We have to find the number of ways so that out of this 19, you don't choose a red ball.
Ma'am, but why is it 19C3 here and 19P3 in the previous question?
P3, where is P?
In the previous question.
No, we haven't worked on permutation till now, in this session at least.
Yes, ma'am. Only
This is
C.
just, okay, forget about permutation or last question or whatever it is. We just want to choose any 3 balls. And that 3 balls should be chosen so that no red ball should be there in your combinations. So when we say out of this 6 plus 4 plus 9 balls, if you choose any randomly any 3 ball, there is definitely there is a one outcome. There are many outcome in there. A red ball will be selected, right? But you don't want red to be considered. So just leave it. So just consider this 6 white balls and 9 black balls. Now choose 3 balls from this combination, 6 white, 9 black. When you choose any 3 balls from 6 white and 9 black, so you are sure that in your any event, in your any outcome, red will not be there, right? So that's why when we are calculating the ways, so ways of choosing the 3 balls such that no red ball is chosen, we will consider this 6 plus 9, 13. So out of this 13, sorry, 6 plus 9, 15. Sorry, it is my mistake. Yeah. out of this 15 balls, now you want to choose any 3 balls. So how will you choose? Out of 15 balls, you have to choose 3 balls. So number of
15 C3.
possibility. So what is this 15 C3 actually? This is the total number of ways of choosing 3 balls such that no ball is of red color. Okay. In this combination, any red ball will not be there. In any of this number of combinations, red will not be there. But this is number of ways. They have asked us the probability of this event. How we calculate the probability of any event? The number of favorable outcomes divided by total number of outcomes. So total number of outcomes are still 19 C3. In that total, we can't remove red, right? Okay.
Yes, ma'am.
Is it okay? Is your doubt solved?
It's clear.
Yes, ma'am.
Okay.
Ma'am, we can do it by using cases also, no?
Sorry, how?
We can
Your voice is not clear
do
to
it
me.
by we can do it by using cases, making cases, different cases.
Yes, you can do it, but see, there will be so many cases. You can do
Yes,
it,
ma'am.
no problem.
4 cases
Yeah.
are there.
So I can explain via that also. I will explain, no problem. So what are the cases? Yes.
Ma'am, in this question, without replacement.
Replacement again.
Without replacement.
Without replacement.
So I have chosen one white ball, one black ball, but third ball is also white or black. So it is
Yeah.
a replacement.
It is a
Replacement.
no, not a replacement. You have 6 choices for white balls. Even though if you have chosen the first ball as a white, second as a black, then how many choices you have for the white? There are 6 white balls. So obviously you can take another white ball again. So
Okay.
yeah, even you have 3 white balls also. Why? Because you have 6 white balls. Out of 6, 3 is possible, right?
3 different white balls, like
Yeah, 3 different white balls. Yeah.
W1, W2, W3.
Yeah. Okay. Say W1, W2, W3, no problem. But when we say numbering, so okay. Because we
I
are
got
using
it.
combination, numbering doesn't matter here. Okay. Fine.
Okay, ma'am.
Someone was asking for the cases. So how many cases are possible? If we want no red ball should be there. So first cases will be like all 3 are white. Let's see. All 3 white. So you will just calculate for this one. Then all 3 are black. For this also you will get this, right? Then the third will be 1 white, 2 black, 2 white, 1 black. Okay. Is there any cases I am missing? No, right? Yeah. So for this, what will be your chances? All 3 whites. What will be the probability to choose all 3 whites?
63.
So 6C3 divided by
19
19C3. Now you will add this with this condition. What is this? All 3 black. How will you calculate all 3 black? Some 9C3 divided by 19C3. And then we will add for 1 white, 2 black. For this, what will be 6C1
into
9C2 divided by 19C3 plus this one 2 white 1 black. So for
6C2.
this, yeah, 6C2 into 9C1 divided by 19C3. We will just add all this. The answer will be same as we did earlier. We just removed the red ball. We just have taken this 6 plus 9, this 15 balls under consideration and find out their favorable outcome. Okay?
I started
Ma'am,
off with
yes, ma'am.
I started off with a
Ma'am,
different method. Can you just tell me if I'm right there? Because I haven't checked it yet. I did that 6C1 multiplied by 9C1 multiplied by 6 plus, already two balls have been removed. So it is 5 plus 8. So that's 13, isn't it? Yeah, 13C1. By the whole thing divided by 19 C3. Would that be right?
Sorry, is it right? Can you see on
So
the screen?
6C1, 9C1 multiplied by again
Uh,
6. From each two balls have been removed. So it is 5 plus 8, that is 13. 13
mm,
C1.
yes, it is right.
Okay, all right, thank you.
It is one and same thing only.
Okay,
You have like considered here 13C1
yeah,
rather than like the same thing. We can do that. This 13 plus these two, that means 15. Out
yeah,
of this 15, you just consider 3.
yeah.
Okay, like both are same.
Oh, okay, all right, thank you.
Ma'am, in the previous question, I didn't get a small concept name.
Previous question,
Yes, ma'am.
this one or
The previous one.
okay, yeah.
Ma'am, here, like conceptually, how do we get the answer, ma'am? Like, we know it like 6 by 19, 6 by 19, then into 4 by 18, into 9 by 17. Then how do we additional 6 multiply to addition?
Actually, your voice is not clear. Can you like you have a doubt on solution or what? Hello, am I audible?
Yes, ma'am.
Yeah. So in this question, see, we want one white ball. The requirement is one white, one red, and one black. Okay.
Yes.
So yeah, what is your question then? Hello.
Ma'am, you're not audible.
Hello.
Yeah, we
Hello.
can hear you. We can hear you.
Okay.
Even
Then what is that girl's doubt, please? Either you can write on a chat.
Ma'am, I have a doubt.
Okay, I think there might be some technical issue with you, internet issues. Okay, we will come back to this question at last. For now, just let go to next question. Okay. Yeah, this one is not done, right? Yeah, this is done. Yeah. So now again the same question, like same scenario. We have to find the probability that at least one ball is white. Okay. Yeah. Just check for this. Now the case is we want to find the probability that at least one ball is white out of that 3 balls.
Ma'am, can you please turn back the slide?
Which one?
Previous slide. This one. Okay, ma'am.
Okay. Okay, done. Or need more time?
Done, ma'am.
Okay.
Done, ma'am.
Yeah. So now we need a probability. We have to find the probability that at least one ball is white. So how will we do that? So probability of one ball is white. That means whenever we are picking up the three balls, that one ball should be white. Either one white, or some say one red or one black, maybe possibility, or one white or two red, one white and two black. So many possibilities, right? This only. Then there is a case that two white, one red, two white, one black, and one case is all are white. So these are 6 cases, but we can calculate it without without going this tedious process. We can go like this, because we want at least one white ball. If we calculate the probability of no white ball is chosen, like that red, no white ball is chosen, and then if we subtract this probability, let's say this probability is some q, then probability of at least one white ball is equal to what? Can anyone predict what it will be? It will be 1 minus q, right? So this will be easy. We have to just calculate no white ball, probability for no white ball is chosen. So how will you calculate the probability of no white ball is chosen? So I have denoted it by q, so I will say it q is equal to. So how to calculate no white ball is chosen? That scenario, how we will calculate. So no white ball means whatever is chosen from some 4 red balls and 9 black balls. So there are some 13 possibilities.
13. Yeah.
So 13 out of 13 we have chosen 3 balls.
3 balls.
But this is number of ways. Probability. How we will calculate the probability? So this will be 13C3 divided by 19C3.
19C3.
Okay. This is our Q value. So, but what we have asked, we want to calculate the probability of one white, probability that at least one white ball is chosen. So we will just subtract this value from 1. That is our solution. Anyone have doubt in this? Then please ask. See, if you will go via this process, this is also correct, but this is somewhat tedious and you have to calculate lots. You have to do lot of calculation. But here directly you can go like this. Is it okay with everyone?
Ma'am, in previous tuition.
Ma'am, how 13C3?
Yeah. So when we have to calculate the probability that no white ball is chosen, this is the 13 is came from, we are calculating probability of no white ball is chosen. Okay. So when we are not considering white balls, so to find out the possible ways, we will just remove these 6 white balls from the scene. So out of this 19, if you remove 6, so it will be 13 only. That means we have choices to pick the balls from 4 red and 9 black. So it will be the number of ways of choosing 3 balls such that no white ball is chosen. You got my point?
Yes, ma'am.
Yeah, okay. So should I
Ma'am,
move
I have doubt. Hello,
Yeah.
ma'am.
Yeah, please.
Ma'am, I have doubt in previous tuition.
Okay. In this question, anyone has doubt, then we will go to previous. Okay.
Yes, ma'am.
Yeah, please.
I mean, how I have proceed like that? we have to choose only one white ball, right?
Yeah.
That's why it means at least one white ball, two may be possible or three may be possible. So what I did, I have considered 6C1 multiplied by 18C2.
18. How 18?
And because we have chosen one first white ball. Then after that we have to choose two balls out of 18.
Yeah, but this doesn't work like that. Like you have chosen 6C1.
Yes.
Okay. And divided by what you just
Divided by 19C3.
19C3. And then you multiplied it with
18C2.
Okay, 18C2.
Yeah.
Okay, so this is only one case. Okay, this is also correct. You have chosen the one white and then two balls you have chosen from this. But in this case, can you say that all the cases are covered?
Yes, we have to choose at least one white ball, and rest of the two balls, anyone we can choose.
Yes, yes, this is also right. Yes, yes.
But my answer is wrong. I'm getting 0.94.
Okay, then it might be some calculation mistake. Let me check.
Ma'am,
Let us check what happened here.
what is the answer of this question?
Yeah,
Is,
we will
I
see the
think
answer.
0.705.
Yeah. Yes. See, in this scenario, what you have done, you have just chosen the first white ball and then rest is out of 18, you are choosing any two balls. Okay. Why you are getting the wrong solution? Now I will explain you. See, when you have chosen the 6C1, in 18C2, there will be out of 18, right? We have what 6 white ball, 4 red and 9 black balls. Yeah, in this 18C2 you are not like whenever they says at least one ball is white, we make to show we have to sure with the condition that there should be a one case where one white ball is there, two white ball is there and three white ball is there. Like these are or conditions. Okay, all these conditions should be considered. So in your case, when you are checking with this condition, you have just considered the first condition only. Okay, that means one white ball. And even in the calculation also, because it is just 18, that means this 18 doesn't define anything. Like it may consider two white, one white, all this, but it will not give you guarantee that all the situations are considered. So when you are going with like this, just be careful that if you are going 6C1, that is right. But beside that, you can't take this value directly. Why? Because there are out of this 18, some 5 whites are there, some 4 red are there, and some 9 blacks are there. And when you consider this condition, these all are equal. Like when we say combinations, then any random two combination will be chosen. Okay, and order will not matter there. So even so when you are go with the 6C1, just be sure that what is your second ball and what is your next ball. Let's say it's a red. What happened? Please mute anyone. Yes. Okay. So yeah, just go for the next ball, which is some red or black. Okay, which might be red or black. Then consider, then add this condition, like this will be for 4C1 and this will be 9C1. Like that you have to go.
But I find the logic to be fine, isn't it? Like, isn't it perfectly okay because you have one ball less, and you should select two balls out of the what do you call 6 plus 4 plus 9 minus 1.
Yes.
That is 18.
So in
Okay.
this 18C2 condition, we have to
Yeah.
just check 19C3, right? This was your
I think that should be right, isn't it?
It is perfectly right. Yes. Then I think
Some calculation mistakes you
that
might have.
girl has done some calculation mistake because in while we consider 18,
Yeah,
that means it has considered all the cases WW,
correct.
WR, RW, all these things are considered. So your answer, your
It should be
logic
right.
is correct. Only just go for the calculation recheck because it is actually correct. Yeah. Are you there? Who have asked the question?
Yes, ma'am. But I don't know what's the mistake I had done.
No, you are doing some calculation mistake only.
Okay, okay. I will
Just
read.
recheck the calculation and like
May I
we
know
can
the
discuss it
final?
last also.
What is the answer?
Yeah.
0.705.
Okay.
This is your answer. See, first go for the logic as you are good in logic. So your logic is actually correct. Now, whenever we start with the probability, just go first look out the logic. First look out the question. Understanding the question is most important. Then just go for the logic to the answer. If logic is correct, then you are 90% done. Now just calculation is there.
Ma'am, how many questions are left?
Like, why are you guys interested in that question always?
Ma'am, there is also math class.
Okay. Sorry.
From 8.
8
That
to
to
10.
8 o'clock.
Yes,
Yes, ma'am.
Okay.
5 minutes left.
Okay, then I think I will take some 10 more minutes. Then we will like finish. Just 2 or 3 questions left.
Ma'am, I have a small doubt in previous question.
Yeah, please.
Ma'am, previous question.
This one. Is this?
Yes, ma'am. Yes, ma'am. Ma'am, can we solve it like 1 minus probability of all red ball?
1 minus
All red.
probability.
1 minus
No.
probability.
1 minus probability of all red.
Yes, ma'am.
That means you are missing these conditions now. 1 red ball, 2 red ball. These are also scenarios now. If you do this thing, then these 2 cases will be missed out. If you consider this one also, then it's fine. Then it should not be like 1 minus probability of all red. It should be like 1 minus probability of at least 1 red. Understood?
Oh, yes, ma'am. Thank you, ma'am.
Are you able to observe the difference between all red and at least 1 red?
Yes, ma'am.
Okay. So you have a class at 4, 8. Okay, fine. See this question. Suresh applies for a job in 2 firms, X and Y. The probability of his being selected in the firm X is 0.7 and being rejected is 0.5. Being rejected at Y is 0.5. The probability of at least one of his application being rejected is 0.6. What is the probability that he will be selected in one of the firm? Okay. As you guys have a next class, I am just allotting 1 minute only. And it is easy question. Now only 2 questions are left. That are easy only.
Ma'am,
Yes.
ma'am, I have a question. A student portfolio regarding with aesthetics extra activity. In
Yeah.
How to create a student portfolio without student ID, because I have not get a student ID.
Actually, you have to do it with the official mail ID only.
But we have published at a particular domain.
Then I
As
think
per given a video.
I published.
Okay. What's your name? Like, I will ask them to solve your query because I don't know how to do that. So
I
that
might
is
publish
another
the
team.
portfolio publicly. All
Okay.
can watch that.
You can ask in like.
As per professor advised to go the student ID, which are given by IIT Madras.
Yes, yes. You
But
have to
we
go
have
to-
not received any student ID.
till now. Okay. Okay, then I will ask them to resolve this issue and they will inform you. Okay,
Okay, ma'am.
how to do that. Okay, fine. So, yeah, done with this question. Suresh applied for the job in two forms, X and Y, and we have given the probability of his being selected in X is 0.7 and being rejected in Y is 0.5. And probability that at least one of his application being rejected is 0.6. And the question asked is probability that he will be selected in one of the firm. Okay. So we'll directly go to solution. Yeah. So A and B, let A and B denote the event that Suresh is selected in one firm X and Y respectively. Okay. A means event, he is selected in X, and B is the event, he is selected in Y. So probability of selecting in X is given, right? It was 0.7. So probability of A complement means he is not selected in X company is 1 minus 0.7, that is 0.3. Probability of B complement is given because we have given that probability of rejecting in Y, right? That is rejecting in Y is probability of B complement actually, because B is the probability of selecting in Y. So probability of B complement 0.5. So probability B of selecting is 1 minus 0.5, that is also 0.5. Now, what they have asked, at least one of the X or Y, he is selected. So that means probability of A or B, right? Either he is selected in A or selected in B. So we just expand it, which will be 1, which is 1 minus probability of A complement intersection B complement. What is A complement? Not selected in X intersection means A complement intersection B complement. What does it mean by it? That means he is not selected in X and he is not selected in Y also. So, okay, we will just subtract this condition. So, A complement union B complement, we have calculated. It is given that probability of rejection is given there 0.6. That's why we are going like this. And the formula for A complement union B complement, that is addition rule. So it is probability of A complement plus B complement minus probability of A complement intersection B complement, right? We have all these values now. So just put it in the formula and you will get the answer. Okay. So is there any issues with
Yeah.
this?
See, if you look at the problem statement, can we just see that?
Yeah, sure. Just a minute. Is my screen visible?
Yeah.
Okay. Yeah.
Yeah. See here, they say the probability of at least one of his application being rejected is 0.6. So which means at least one of his application being accepted should be 0.4, isn't it? Straight, direct.
See, probability of at least one of his application being rejecting. What does it mean that? It means it is considering that both the condition. It's rejected in X. Okay, one condition, it's rejected in X. Second, it's rejected in Y. Third, it's rejected in X and Y.
Oh, so both X and Y also gets rejected. Okay, I understood. Got it. Thank you.
Okay. Okay. So with solution, anyone has doubt? Okay. Hello. Okay, we will move to next question then. Yeah. Given 5 numbers and 2 alphabets which are to be placed next to each other for making a security password in a laptop. What is the probability that there are exactly 2 numbers between the 2 alphabets? Okay. Let's try this question. Am I audible?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, fine. If it's done before the time, then please tell me, so I will stop the timer. Okay, this is the last question only. Okay, done. So here 5 numbers and 2 alphabets are there, and we have to place them next to each other, and to find the probability that there are exactly 2 numbers between 2 alphabets. Okay, so how will we proceed for this? Okay, many less, only 7 has replied for this. Is question clear to everyone?
Yes, ma'am.
Sir, repetition
Yes,
is
ma'am.
allowed or not?
No, because we have 7 positions and 7 like no, 5 numbers and 2 alphabets only. So how you will
Password
repeat?
is just seven digit.
Yeah. And yes, you have to use by this. If it is not mentioned, we will not allow repetition. Okay, you want more time for this to type your answer? Then I will give some 30 seconds. Okay. Okay. So yeah, there are 5 numbers and 2 alphabets. The condition is password should be such that there should be exactly 2 numbers between 2 alphabets. So by this line, we will first check. See, there are some 7 positions now. 1, 2, 3, 4, 5, 6, 7. Okay. Out of this, the condition is on alphabets and numbers, that these 2 alphabets are such that if let's say this alphabet A1 is there, and then A2 should be here only. Why? Because the condition is exactly 2 numbers should be in between these 2. So we will concentrate on this condition. So first, let's find how many possible ways for these 2 alphabets to take the position. Out of these 7 positions, how these 2 alphabets can be arranged. So when we are finding out the total possibilities, at that time we will not consider this condition, right? At that time we will consider, okay, first alphabet is, if it is ticked here, then for second alphabet there are 6 positions are left. So what will be our total possible ways to arrange the 2 alphabets? How many ways are there? So it will be 7 into 6, right? Which will be 42 ways. Is it fine? Now, we will check how many ways are there so that exactly 2 numbers can be in between these 2 alphabets. So, for this restriction, we have to just go by the cases. So, let's say case 1. We will first fix the alphabet's position. That means first alphabet is on first position and second alphabet is on the 4th position. Okay.
Ma'am, here total is 42. How to calculate?
For first alphabet, how many choices you have? There are
one choice we consider in our first case.
Yeah. So when you will just first put the alphabet, okay. See, you have alphabet and you have 7 positions. For the first alphabet, how many positions you have? You can put first alphabet here, anywhere, right?
Yes.
So there are 7 ways to place the first alphabet. So let's say you have placed your alphabet here, A1. Now A2 will come. A2 is your second alphabet. For the second alphabet, how many choices you have now?
6.
6 only. So this 7 into 6 possibilities are there for to place 2 alphabets, right? Now,
Yes.
Now we are looking for the condition that 2 alphabets should be placed so that in between them only 2 numbers should be there. So if I place my first alphabet at first position, my second alphabet should be on the 4th only, so that second and third can be taken by numbers. Okay. What will be the case 2? If first alphabet is at second position, where I can put the A2. If it is on second, and yeah, second, 2, 3, 4, 5, fifth, right? Similarly, for the case 3, if my first alphabet is at third position, second should be at 4, 5, and 6th position, and then 4th and 7th, right? These are the only possibilities that I can put my alphabets. So yes, just here is the solution. Can you go ahead of this? Now, how will you choose For this first case, how many possibilities are there? See, for this two, if your let's say your two alphabets are, let's say, A and B, okay, A and B, and as it is a password, it matters that first position is A and fourth position is B, or first position is B and fourth position is A. So for case one, how many possibilities are there? Two possibilities. For case two, again two. Case 3, again 2. Case 4, again 2. So, my favorable outcomes are 2 plus 2 plus 2, 4, 8. Right? My favorable outcomes are 8 and total outcomes, total possible ways are 42. This is my probability. I will just show you the explanation because it's late. We are going late, right? See, if anyone has doubt, please ask me. See, sorry, yeah.
Ma'am,
Yeah.
can you explain that after, like, how it's 2 and 2 and 2? Like,
Yeah. See, there are some total of 7 places to arrange the two alphabets. Okay. Therefore, the number of ways in which two alphabets can be arranged is 7 into 6, that is 42, as we discussed. Okay. Positioning of two alphabets such that there are exactly two numeric in between them. So we will first fix their position. Let's say first alphabet is at first place and second is at fourth place. So this is one case. Okay, when your first alphabet is at first position and then two numbers, and then second alphabet is at second position, fourth position, then again 3. Okay. 4 and 3, 7, yeah. Huh. This is one case, okay? This is one way. The another way will be like A2 will be on the first position, then two numbers, and then A1 will be there, and then again 3, right? So in this way, there are two ways are there for this case 1. Someone has asked out, is it clear? Like, is it clear to
yes, ma'am. Yes,
yeah.
ma'am.
Okay. So then what we have case 2. So your first alphabet will be at second and second will be at fifth. And then similarly, we will alter them. So there are two ways again. And then case 3, your first alphabet at third position and second at sixth position. Okay. Then similarly, we will go for the fourth case also. And via that you can get that there are some 8 possible ways for the given condition, and total outcome is 42. So 8 by 42 will be your solution. Is it okay?
Yeah, ma'am, got it.
Okay. Then now here is one feedback.
I have one conceptual doubt here.
Yeah.
Please show me the solution. Just
Yeah. Yes.
so we are working it out. We are working it out as 2 plus 2 plus 2 plus. I mean, we are only considering the placement of the two alphabets, correct?
Yes.
But since this is a password, it has to be a kind of permutation, isn't it?
Yes.
So which means the in between numbers will have too many permutations. So
Yes.
so for every such combination, shouldn't this placement of alphabets be more than 8? More than 8 ways? Like, I mean, it's an intuitive doubt.
See, when we have two, there are two alphabets, right?
Yeah.
So two alphabet, among them, how many times they can permute?
Two times.
Two
Just 2 times.
factorial way, right? So, and there is a condition that there should be exactly two numbers between that two alphabets. Okay.
Yeah.
So for that we have to fix the alphabet's position. Let's say
I understood the solution. I understood, so it's perfect. A very
okay.
clear solution. Yeah. But
Okay.
this doubt is conceptually, I thought since there are too many numbers in between, so for every permutation, only 8 such possible alphabetical arrangements. I mean, that's my doubt. That's my question.
For alphabet only like 8 permutation, 8 ways are there. If
Yeah.
we can consider the permutation of numbers also, because number
So,
among themselves will also permute, right?
okay.
When there is a A1 is there, let's say, and for 5 numbers, I am saying that these are 1 to 5, okay?
Yeah.
Let's just consider that
Yeah.
cannot be fixed. That can be any 5 number, any 5
Correct.
digit. Okay. So like that. So this may happen that now at this position 1 is there, at this position 2, 3, 4, 5. So these numbers also can permute among themselves. Like A1 is there and this 2 is there, this 1 is there, A2. And this,
Yeah.
like for this case, we have 5 factorial ways, right?
Yeah.
5
So it means
factorial.
the A1, A2 is repeating so many times. So wouldn't that be like so many possible ways of uh, the event A1 and A2 being in that position? Whereas we
Yes.
only considered 8.
Yeah. So, but we can have, no doubt, we can have like that, no problem. Let's say. So, how many possibilities will be there? Let's calculate. So, for A1 and A2 at this position, 5 factorial. Then we will flip this A1 and A2. So, now this is multiplied by 2. And the same thing we have to consider in the total cases also. Like when there
Ah,
are 42 cases, we have to multiply this thing again there also, 5 factorial
correct,
multiplied by 2.
correct, correct.
So, this will cancel out.
Oh, they cancel out. Okay.
Yeah.
Oh, okay.
Yeah, but your doubt was correct. Yeah.
All right. Thank you.
Okay. I hope I have cleared your doubt.
Yeah, yeah, perfect. Thank you.
Okay. So yeah, there is last feedback is there. Please reply here, and you can then leave. So understanding of the concept for week 7, is it like you just read and reply? If anyone has doubt, they can please ask. I am here. You can ask me, or it's okay.
Ma'am, I have a doubt.
Yes.
Ma'am, like the questions which you have discussed about the without replacement and all these questions, ma'am.
Yes, we will go to this that question again. If you can stay just for
Yeah,
few
yeah,
minutes.
ma'am.
Yeah.
Yeah, ma'am.
Just this feedback is there. That's all. But many of the people are not replying. Okay, no problem. Yeah, this was the last. So anyone wants to leave, they can leave. Those who have the question, please ask here. Okay. Without replacement.
Like, ma'am, you
Balls.
can,
This
yeah, the
one.
very first question, yeah, ma'am. Ma'am,
Yeah.
actually, how will I know that I have to go towards the concept of permutation or combination? Because I was simply approaching the probability concept. Like, I did a stupid mistake. I was going through like 1 by 6 and plus 4 by, like 1 by 4 plus 1 by 9, ma'am.
See,
So,
what you have done, 1 by 6 plus, sorry, can you repeat what you have done?
yeah, ma'am, I was just taking the favorable outcomes upon total number of outcomes, like 1 by 6 plus 1 by 4
Yeah,
plus 1 by 9.
yeah. For this question, sorry, what was that? What that none is the red color. I guess you are talking about that one red, one white like that. Okay. See,
Yeah, ma'am.
when you are taking 1 by 6 plus 1 by 4 plus 1 by 9, whenever there is such a doubt, the best practice is to just read the whatever you are writing in mathematical. Just read in words. What does it implement? What does it imply? When you say 1 by 6, what does it mean?
Like
1 by 6.
selecting,
Yeah.
sorry, selecting one ball from the 6 balls.
Yeah, right. Selecting one ball from the 6. Right. This is the question. This is your implementation by 1 by 6. And you are adding that 1 by 4. 1 by 4, what does it mean?
Selecting one red ball from the white ball.
So yeah, you and addition means you are taking two events that are totally independent to each other. Let's say You have just selected one balls out of white, or like this means or. You have selected one red ball out of this 4, and this is not, this is the probability of selecting one ball, right? Out of 4 red. And then you choose this 1 by 9. In this case, actually, what this says, can you give me the implication of this 1 by 6 plus 1 by 4 plus 1 by 9? It means either you selected one balls out of the 6 white ball, or you selected one ball out of the 4 red ball, or you have selected one ball out of the 9 black ball.
Yeah, ma'am. And if I would have multiplied like 1 by 6 into 1 by 4 and into 1 by 9, that will also be wrong. But ma'am, why it is wrong then?
Yeah. See, for this type of this type of mistakes are very common in probability. So just don't be afraid of that. See, the question is, find the probability that one of each color. See, there were 6 white balls. Okay. They are white means you do not need W1, W2, W3. You can take for your convenience, but no need, right? Okay. So just consider the real life scenario. There is one box in which there are 6 white, 4 red, and 9 black balls. Okay. So out of this, you are just picking 3 balls. Just let's say you have this is real and real scenario, and you are picking 3. So what will be your outcome? Can you just tell me? It may be anything, right?
Yeah, ma'am.
It may be anything. So for anything, you just calculate how many possibilities are there. So how will you calculate that possibilities? Okay, just consider one person 1 is picking up 3 balls. Person 2 is picking up next 3 balls. Okay.
Yeah, ma'am.
So both the combination will be same or different. Like it
can
may
be
be same, it may be different, right?
Yeah,
But
ma'am.
how many different ways are there? So in that case, when you have to just pick any 3 items from the given items, at that time you have to use combinatorics. Okay. Combinatorics at that time you have to use. Why? Because combinatorics gives you the number, gives you the count. Out of total n number of items, you are choosing some r number of items. Okay. And in this case, the same thing is going there. Some 6 plus 4 plus 9. That means 19 balls are there, and you have to choose 3 balls. Okay. So whenever there are some selecting kind of things and there is no ordering there, then you just remember combinatorics. It will be 19C3, right? You got this point first?
Yeah, ma'am.
Okay. So this is one part. So this is what is this now? In the context of this question, what this 19C3 represents?
Like the total number of the balls.
Total number of the balls are the 19.
Yeah.
So what is this 19C3? In language, it is the number of ways so that we can choose 3 balls out
from
of
the
the 19 balls. Okay.
Yeah, ma'am. Yeah, ma'am.
So it is that condition. Now, if I say you have to choose, you have 6 white ball and you have to choose 1 white ball, how will you choose?
6C1.
6C1. Why didn't you choose 1 by 6 as you choose last? Like in your, when you were attempting, you did this, right? You were telling that.
Yeah,
Why
ma'am.
didn't you choose this and you choose this? What is the difference between these two?
I mean, that case of combination, like I can select any one ball.
Yeah, you can select any of the 6 ball. And what is this? This is probability of selecting one ball when there are 6 balls. Okay. Are you getting the difference between 1 by 6 and 6C1?
Yeah, ma'am.
1 by 6 is the probability that out of 6 ball you are selecting one white ball. So what will be the probability? The probability will be 1 by 6, right? But we want how many ways you can choose one ball out of 6 white ball. So it is 6C1. Okay. Similarly, I will ask how will you choose one red ball out of the given 4 red balls?
4C1, ma'am.
4C1. Okay. So,
Yeah, ma'am.
so this is your, let's say, just a minute. This is your 4C1. Okay. And you have already chosen one white ball from the white, right? From out of the 6 white ball, you have choose one. And now you have to choose one black ball. How will you choose? That will be
9C1.
9C1. Now, why do you have to multiply this? Now this is question, right?
Ma'am, because we want the 3 balls. So
Yes.
we will multiply only.
We will multiply them. So if I just consider this multiplication, what this multiplication represent? Can you say, can you like switch this expression into words? Can you explain what is this 6C1 into 4C1 into 9C1?
And
Not end. We whenever there is some expression, it has some meaning, right? So what is and like a context you have in your question, and now this is expression. How
Yeah,
will you
ma'am.
explain this in terms of context?
It means selecting one ball from the 6 white balls, selecting one red ball from the total 4 red balls, and selecting one black ball from the total 9 black balls.
Yeah, and now just go to this line. What this line is? What we have to find? Find the probability that one is of each color. Have you considered each color in this your expression?
Yeah, ma'am.
So that's why we have did this. And now this is total number of ways of choosing like different color
Ball.
of balls from that combination, right? So this is number of ways, but they have asked you probability. So for probability, what is the like formula? We just go by favorable outcomes
Yes.
divided by total outcomes.
Yes,
What,
ma'am.
what is your total outcome now?
19C3.
So that's what we have done.
Ma'am, I was making mistake. I was just taking any 1 by 6. I was considering that, and here I have to select the ways in which I can choose the balls.
Yes. So are you clear now?
Yeah, ma'am.
That's more important.
Thank you, ma'am.
Okay, then. Any doubt?
Yeah, ma'am, and one more, ma'am.
Yeah.
Ma'am, the question where you have mentioned like the biasness dies and the unbiased dies, ma'am. Ma'am,
Biased, unbiased, that might be the first question, I guess.
and the
Yeah,
second.
this one.
Yeah, ma'am.
Unbiased,
And here, yeah, ma'am, here I understood that unbiased thing, and biased thing I also understood that it is more like focus on the some particular, like for the coin case, like head or like it's mistake. It's
yeah.
technically more towards that thing. But ma'am, you have talked about dice, then it was like probability of 6 is equal to 1 by 2 of the biased dice. Ma'am, how?
No. I have just randomly chose the like probability of 6 1 by 2. It might be anything. Like, see, if your dice is like something like this, right? Okay. See, if there is a dice and that dice is such that if your one of the side is very heavy, okay, let's say that side is this one in which there are 6 dots, 1 2 3 4 5 6, okay, this is 6 this is the side in which there is a 6 dots are there, okay. So let's say the manufacturer has made some mistake or somehow it is unbiased that whenever you throw, this 6 will be on upper side. Like there is some mistake that this part is heavy or somewhat, whatever the thing required is. Okay. If this 6 will come again and again, then obviously this probability of 6 will not remain 1 by 6, right? Because it's not a fair dice. This probability of 6 will no longer will be 1 by 6, because see, in simple term, when there is any unbiased thing, let's say unbiased dice, if it is unbiased dice, then whatever the outcomes are, they should be equally likely. Then only we will say that the dice is unbiased. Okay. 1, 2, 3, 4, 5, and 6.
Yeah, ma'am.
Okay. The scenario till when this probability of all these numbers is 1 by 6, then only this dice will be unbiased. Whenever you play any game at that time, you can expect any number, right? If you are playing with the dice, you
Yes,
can
ma'am.
expect any number. But think about the scenario. If someone has made something mistake in while forming the dice, so that your dice is again and again giving 6 only, and sometimes only 6 it is giving. Why? Because there is some manufacturing mistake, and that's why that dice is always landing with the 6. Okay.
Yes, ma'am. Yes, ma'am.
Are you understanding my
Yeah,
point?
ma'am. Yeah, ma'am.
So that's what the difference is. So I just randomly took the example that, let's say there is some dice which is by mistake it is made that probability of getting 6 is 1 by 2. So
Okay, ma'am.
probability of 1 until probability of 6, it should be so 1, right? Probability of all the events should be equal to 1.
Yes,
So
ma'am.
when probability of 6 itself is 1 by 2, then it is obvious that all this probability can't be equal to 1 by 2.
Yeah, ma'am.
Why? Because probability should be 1. And if
Hmm.
all these are 1 by 2, why we
Hmm.
are searching for 1 by 2? Because we are saying that it's unbiased. If it's unbiased, that means probability of each and every event should be 1 by 2. So if
Yeah, ma'am.
all these are 1 by 2, then sum will be 3. So it is not possible. So if probability of 6 is 1 by 2, that means probability of 1, 2, 3, 4, 5 will not be equal.
Hmm.
That means that dice is biased.
Biased. Okay, ma'am. I got confused with that, but why you have written 1 by 2. Now I got it, ma'am.
Okay.
Thank you, ma'am.
Okay. Thank you.
Ma'am, in the last doubt, when it is not written anything like repetition or non-repetition, then what we have to consider repetition case?
Generally, we do not generally there will be question will be very clear in maximum of the cases. But if it is not, we will consider without replacement.
Without replacement.
Yeah. But but maximum of the times, don't worry, the question will be very precise. There will be clearly, they will mention it is replacement is there or not.
And ma'am, replacement is equal to repetition, no? Like we are saying
Yes, we can
without
say
replacement.
that, but in general in general speaking, it seems something different, right?
Yeah, ma'am, but in case of solving problems, like
Yes,
there were
yes,
EMQs, so we can say that without replacement is equal to without repetition only.
yes, sure. Why? Because you have used one times, that means you can't repeat it. You can't repeat it. That's what without replacement. You can definitely say it. No problem.
Okay, ma'am. Thank you, ma'am.
Okay, thank you.